Okay, so in the last section we were unable to finish all the slides. We were unable to go through the QML example. So let's do that now. It takes maybe about 10-15 minutes, something like that. So last section we talked a lot about what QML is. So let's take that knowledge into practice and let's see what it actually looks like. So we have this nicely animated piece of source code. This is the beginning of a QML UI file. What we see here is a simple rectangle that acts as the basis of our UI. Let's see a bit more. We have text. Do you see where this is going? We are aiming for this kind of view. So we had the base, the rectangle, which acts as the container of our UI. Then we had a piece of text. We have an image. And then we have something called mouse area. So that piece of code implements this kind of view. Basically what we have done is that we have described what we want to see. Let's go through all the details of that code. We'll cover this quite quickly because I assume that many of you are already familiar with the basics anyway. So the elements that we have seen, the built-in QML elements in the previous example, were rectangle, item, text, and image. Quite obvious what they represent. And then there was the other part. There was this import clause in the beginning of the file. Import Qt Quick 1.0. So that import clause specifies what we are going to use, what we are, in a way, a namespace that we are going to use, a module that we are importing into our application. In this case, we bring the built-in basic elements of Qt Quick. In the previous days in Qt 4.7.0, when QML first came into Qt, the import clause was a little bit different. At those days, we said import Qt 4.7. And this is also something that you still need to do on N900 MIMO device, except if you install the Qt Quick Compats package. A question. Can we have the microphone, please?
Right now, when targeting multiple platforms, it is necessary to use the import Qt 4.7. For how long will this be supported in Qt?
You mean while targeting multiple platforms?
Multiple platforms, for example, the N900 running Qt 4.7.0, which, for example, needs this, or the VTab, which also ships with Qt 4.7.
Well, that's something that we are going to discuss in the next section. Basically, what it means to implement your UI so that it supports different platforms. But my understanding, I cannot make any promises, obviously, but my understanding is that these modules are something that are going to remain in there. The version numbers are going to remain.
Okay,
so I would assume that it's staying there, but obviously I can't promise that. However, there is a package, Qt Quick Compats for N900, that fakes Qt Quick 1.0 module or namespace. So if you install that, then you can use applications that require Qt Quick 1.0, and they still work on N900. And you can, of course, make your application depend on that package, on that platform. Okay. So how about the other parts of the UI? The elements in this UI form this structure, a hierarchy. There's the rectangle, that's the parent, the containing elements of all others. Let's call it root. And then we have a number of other elements, text, image, and mouse area, that are child elements. Each QML file needs to have a root element, always one element that contains other elements. Then these text, image, and mouse area, they are called visual elements, and they all inherit item. Well, the rectangle is also a visual element. They all inherit something called item. Now, this is very similar to class hierarchy in object-oriented languages. They inherit the properties of their parent element. And when you check the documentation, you can see which element inherits what from where, etc. So visual elements have a number of common properties, like ID anchors X, Y, Z, width, height, things like that. Then some implementation details, mostly so that it's easier to follow on these slides, because we need to condense the examples a little bit so that they fit on the slides. If you want to put many things in the same line, you can just separate them with a semicolon, as can be seen in this example. Then I mentioned earlier that there's this ID element, and that's something special. It's used for giving a name for an instance of that element. So in this case, we are instantiating this text element, and we give it name hello text. Yeah, this is good. Okay, thanks. Okay, and this ID can then be used for accessing accessing the element from other elements. Like, for example, in here, we are addressing this hello image and accessing its visible property. So this is hello image, and it has a property named visible. And similarly, hello text property here is being modified. Another special property is parent, that refers to the immediate parent of that element in the hierarchy of the UI. So in this case, for example, the parent of this mouse area is the root element, the rectangle. Then we'll go forward to how to design your UI to make it dynamic. Let's talk a little bit about layouts, how to lay out your elements in your UI. There are a couple of ways of doing this. Obviously, what you can do is to just specify X and Y properties, for example. But that hasn't been a good idea for 10 or 15 years, something like that. And it's not a good idea in this area either. You want to make your UI such that when it gets resized, the content can react. And one way of doing it with QML is to use anchoring. So we can anchor these elements to each other. Each element has a number of anchor lines. They have left, right, and horizontal center, top, bottom, and vertical center. And an item can be anchored to another item's anchor lines. There are also margins for anchors, so you can define left, right, top, and bottom margins, which are taken into account when the anchors are put into action. So when your element is attached or anchored to another element, if you have set up a margin, then they are separated by that margin. One thing is that you can only anchor your elements to immediate neighbors or siblings or to their immediate parents. You can, of course, use another mechanism to get around that. So let's talk about it in a few minutes. But first, an example of anchor layout. So what does it really mean? Let's say we have two rectangles, a blue rectangle and a red rectangle. And we anchor the red rectangle's left anchor to blue rectangle's right anchor, like this. What happens is that we get them side by side. So we don't need to specify a location for this red rectangle. It will be positioned so that its left side sits snugly on the right side of the blue rectangle. Okay, let's add some margins. Let's say 5 units. And this is what we get. A little bit of separation. Then when we add more anchors, top anchor from red rectangle to blue anchor, blue rectangle's bottom anchor, we get this sort of checkerboard positioning. Okay, that's relatively simple, right? Let's go forward to positioners. The layouts, anchor layouts that we just saw, they are for setting up your UI so that things can be anchored to each other, obviously. But what if you have a number of items, you might not know how many, and you just want to put them in a row or column? Well, you can use basic positioners for that, and they enable you to position elements. There are 3 positioners: grid, column, and row. These sound quite similar to what we have in Qt itself, in the widgets. In widgets, we have grid layout, we have column layout and row layout, but they are not similar to positioners on QML. Layouts actually lay out the items. They are able to manage the size of your items. But positioners only manage position. And that's an important difference. This means that when you are using positioners, you always need to define the size of your item. Otherwise, the positioner doesn't know where to put the other items. It only manages X and Y position. If you're using grid layout, you can either put your elements in a grid that is filled by rows or by columns. In this case, we specify the number of columns that we want. We want 3 columns. And then we start adding items. Items are added first from left to right, and when the column fills, then we go to the next row. If we specify the number of rows that we want, then we'd fill by rows, and add more columns as we go. You can also combine different kinds of layouts, like for example, row and column layouts, like this, to achieve something a little bit similar to grid layout, but with better ability to control what you have. So in row layout, we are adding items inside the layout. And they will be positioned in a row, like here. And in column, we are adding items, one of which is the row. And they will be positioned in a column, like this. Okay, so that's it for laying out things. There's a couple of more slides in this set, so let's cover those quickly. So there's, first of all, let's talk about event handling and signals. Now, this is something that it helps if you know how signaling the signals and slots mechanism works in Qt, and how the meta-object model enables you to take a Q object and find out what signals, what slots it has. Basically, there's these signals that we are using in Qt applications. They are also available for QML. We will discuss a bit later how to implement those and how to communicate between C++ and QML. But for now, let's just focus on what we can do with them. So when we want to catch a signal, what we do is that we define a property, a special property that's able to handle a signal. We have actually seen that in the example already. We had this mouse area, and it had onClicked property. And that onClicked property is a signal handler in QML. And for handling input events, we are going to concentrate on mouse area. That's the thing that we have seen, and the one that we will be using mostly. So mouse area is something that enables us to receive mouse events and react to mouse events. Things like click or tap or on mobile devices. It supports a number of different signals like click, press, release, very similar to what we can do with events on Qt. One thing that you should know is that by default, you only get one button. By default, it's just the left button of your mouse or one tap on a touch screen. But if you want, you are able to define what buttons you want by modifying the accepted buttons property. So let's go to an example. We have a simple rectangle, we have a mouse area, and in that mouse area, we trap the onClicked signal. Now, when the mouse area is clicked, then we can react, and in this case, we are using console.log to print out some messages, in this case, the coordinates of the click, to the console of the application. And we can do other things as well, like hide our parent. Some other things to note from this is that there's this anchors.fill, which is, in a way, a special anchor. It enables you to fill your parent elements. A bit similar to anchoring left to left, right to right, top to top, and bottom to bottom, but in a condensed form. Okay, so that was very short introduction to QML. A couple of examples just to show you what it is, what QML applications are.